that we go out and we collect data, and from that we can conduct our research and see what's changing, how can we help this. When you're in the central possession sound, you can see a 360 of all the land around you and the other islands and water. You can see the food web. When you see the top of the food chain.
It's a great day for us to spot porpoise. Yeah, right there.
There's one in front of the harbor.
But then we're also collecting these tiny little plankton in our plankton net where we go back into ORCA and we count them. I mean, you definitely see how it all connects. There are a lot of species that are affected by the changes that are lower in the food chain.
Permission to drop.
We still have a window of time to change, but that window is closing rapidly. The scale of change is just so unprecedented and so unseen that it's going to be hard for things to adapt.
It starts to really wear down on this whole ecosystem that we have here in the Northwest, and really this giant blue ocean that we have on the whole globe.
Ocean acidification isn't talked about enough. It's like the lesser known twin of global climate change. So we're already starting to see major effects, but it's going to get a whole lot worse. And that's why it's important to us, because we need to be able to mitigate that damage before it can reach us.
Let's do ocean acidification, and let's start with the pH scale. And you guys did some pH stuff, what, yesterday, yeah? Ocean acidification is a relatively unique problem in that the students of today and their children will be the ones that feel the greatest impact of this problem. Ocean acidification is caused by the oceans absorbing carbon dioxide. As the ocean absorbs carbon dioxide, ocean waters become more acidic. Now, the oceans have always absorbed carbon dioxide, but recently, the carbon dioxide in the atmosphere has reached the rampant stage. It's this rampant carbon dioxide that the oceans can no longer absorb and is affecting seawater chemistry. The pH in the ocean is changing as a direct result of human-caused carbon dioxide releases into the atmosphere and/or through things like storm drains into rivers, into streams. Rivers always connect to the ocean. Natural carbon dioxide, regular and rampant carbon dioxide. It's the rampant that we're trying to do away with. 9.7 billion tons of carbon dioxide released into the atmosphere every year. Greater than 95% of it is released by coal-burning power plants and internal combustion engines, automobiles. Everybody in the world is connected to ocean acidification.
What stunned me about ocean acidification, every day, every person on the Earth essentially chucks a bowling ball of carbon dioxide into the ocean, which there are a lot of people on the planet, and that's a lot of bowling balls, and that's a lot of greenhouse gas. The implications of that, it not only affects the 600 species, calcifying species in Puget Sound, it also impacts the entire ocean.
In the United States, do we burn coal? Absolutely, we burn coal. Tens of thousands of jobs are connected to coal burning power plants or to coal mining every single day. Coal trains go through. A huge portion of carbon dioxide is directly related to coal burning, a huge portion to cars, internal combustion engines. Even during the Industrial Revolution years, when England started burning a lot more coal, when the United States burning a lot more coal, other countries started burning coal, nothing happened as dramatically as what happened in about the 1950s. 2 cars in every garage mentality in the United States. Cars equals internal combustion engines.
Why be stuck with one expensive car when you can enjoy all the fun and freedom of 2 fine Fords?
Today, more and more families are finding out how easy it is to become 2 Ford families. You can choose from 20 different models.
This is a portion of what we're calling the rampant carbon dioxide, things that we have to do away with. So the concentration of carbonate ions needed for shells is going down because we are pumping too much carbon dioxide into the ocean. Starfish, a sea star. Crabs. You see crabs, you see, this is a pinto abalone, an endangered species. How about this one down here? Oysters. All of these things depend on the availability of calcium carbonate in the ocean. And actually, here's how scientists in Washington found out about this. 2005 to 2009, oyster larvae started dying off. Healthy oyster larvae on the left at a pH of 8. You see healthy oyster larvae days 1, 2, and 4, and on the same thing, on the right-hand side at a pH 7.49, you see that the shell is beginning to collapse in itself. It looks like a big piece of wadded up chewing gum. Oyster larvae cannot survive under this condition.
The oysters that you eat or the clam chowder that you have at Ivar's every day, all of those wonderful shellfish meals are not going to be able to be sustained if we don't mitigate the effects of ocean acidification.
You have to be thinking about throughout the entire spectrum of animals out there in order to really understand ocean acidification.
Every place down here, down below the sea lion, an organism that has or is dependent upon calcium carbonate. There's lots of them. Shrimp, crustaceans, gooey ducks, bivalves, mussels. If you remove any of those lines that connect to it, the creature above that has to find something else to eat. And if that creature finds something else to eat, then the other creature that eats that has to find something else to eat. Pretty good chance that these creatures will not be able to evolve that quickly. It's all connected together. I don't want the students to take my word for it. I want the students to understand it and learn more about it by participating in a lab that shows them what happens to seawater when carbon dioxide increases. If this represents the ocean, or there's usually one point in the presentation where the lights come on. There's an aha moment that I see in the students where they begin to understand the problem.
Oh, so it kind of like reached its point.
Bingo!
Oh, yes!
The socioeconomic impact of ocean acidification, if we don't help you figure out what to do about it, it can be huge because 1 billion people worldwide need to have the ocean for protein. By 2045, they're telling us that the oceans will reach a point where they possibly won't be able to absorb anymore and the food chain could start deteriorating at that time. So right now, all we know what to do is to reduce carbon dioxide emissions.
We didn't start the Industrial Revolution, but we can be the solution to the problem because our children and our grandchildren will be seeing these effects as well. I'm not looking forward to what's going to happen for their generations just because if we don't start working on the solution right now, it's going to be a huge problem for them. And I don't want to just keep tossing it on to just sweeping it under the rug for them to deal with.
One of the most important things you can do is to begin to understand ocean acidification and find out what steps you can take to help prevent it. Specifically, if you have an opinion on coal-burning power plants, you can let your legislators and lawmakers know. You can also do simple, easy things. Things like driving your vehicle less, picking up pet waste, using fertilizers properly or not at all, and not washing your car on city streets. It's these last few concrete steps that will help buy scientists more time as they try to find a solution to the global ocean acidification problem.